Alright guys, welcome to lesson 9.4. Today I'm going to introduce you guys to something known as the change of base formula. You can use that to evaluate logarithms that you wouldn't be able to evaluate in a different way based on what we've learned so far. So for example, if I were to give you guys this one, you should be able to figure that one out pretty decently. Now you guys don't need to write this down in your notes. This is just for discussion purposes. But we've talked about how to do this. So basically when we see something like this, we think to ourselves, okay, so 4 raised to what power is 16? And the answer is 2, right? So we've done ones like that, and we should be able to tell that that one is 2. Now, what if I gave you this, though? 4 to what power is 10? Well, we know that 4 to the first power is 4, so 1's too small. But we just realized also in the last problem that 4 to the second power is 16. So if I make it a 2, then that's 16. That's too big. So 10 is between 4 and 16, so the answer here should be between 1 and 2, but we don't know what it is. And so we need to find a way to figure out a problem like that. And the issue is that there's no way that I can get this base to match this one. I can't write 10 as a power of 4. So what we need to do then is change the base. So I'll show you what I mean by that. So suppose for a moment that I have this, and I don't want it to be base B. I want it to be some other base. And I want to know, what does this thing equal? So I'm just going to put x there, right? Well, the first thing that we're going to do is let's go ahead and change this into exponential form. Now, I want to get that x by itself. So what I'm going to do is I'm going to do some log stuff. I'm going to log both sides. Now, when I do this, I'm going to choose a base of 10. Now, you don't have to actually write it, but I'm going to choose a base of 10. Matter of fact, I think I'm just going to make that a new step. So log base b of x equals log of a. Remember, when you do base 10, you don't have to write the 10. So what I've got now is I've got a log up here, but now it's a log with a base of 10 instead of the base that I had up here. Why is that beneficial? Well, I'll get to that in just a second. But there's that. So I changed it into exponential form first. Then I log 10 both sides. And now I'm going to use one of our log properties. One of our log properties says that if you have an exponent here, you can move that x to the front. And now I want to get x by itself, so I'm going to divide both sides by log base b. So this goes away, and I end up with the fact that log x is equal to log a over log b. All right, so what I've done is I've just used a lot of properties and facts about logarithms to do this. And you might think, well, what the heck did you just do, Mr. Bailey? Well, what I've done is I've figured out that this, which was equal to x, is therefore equal to that. So let's write this on our papers. This part is very important for you to write. This is what we call the change of base formula. So I just found another way to do this, and it's by doing this. Now, why did I choose base 10? Because our calculators do base 10, and our calculators also do base e. So I could have done ln also, but I chose 10. And this is called the change of base formula. So now when you come across a problem that you can't do by hand, you can use this formula and let your calculator do it for you. The reason you have to use this formula is because calculators don't have logarithms in other bases. They only have it in base 10. So what we're doing is we're changing this logarithm from a base b into an expression that has logs with bases of 10, and then we can use that to get the same answer. And that's what we call the change of base formula. So let's illustrate that for you. So how the change of base formula works is as follows. Whatever number's here, that goes on the top, and whatever number's here, that goes on the bottom. and both of them are being logged with a base of 10 there. Okay, so in this case, if I wanted to do this one, even though I already know the answer, I know it's 2, 4 to the second power is 16. I just want to show you guys that the change of base formula works. We're going to log 10, the top number is 16, and we're going to log base 10, the bottom number will be 4, and we're going to let our calculator do this work for us. Okay, so how do you do this on your calculator? Well, different calculators work differently. Okay, so we'll have to see how that works for you guys in class. Some calculators you have to do top and bottom separately, so you'd have to find log of 16 first, and to do that you would just push 16 and then log on your calculator. Other calculators will let you type this whole thing all at once in there. So on my calculator, it's a one that I can type in all at once. So when I type it, it's going to look like this. And after I push equals, I get 2. Okay. Now, maybe you're using your cell phone, and your cell phone doesn't allow you to actually type everything in there all at once, then what you would have to do is you'd have to push 16 first, and then you would push log, and then you would have to push divided by, and then you'd push 4 log, and then you would push equals. So try that right now in your calculators. See which way works for you. You should come out with an answer of 2. All right. So either way, though, pause the video if you haven't tried on your calculator and give that a try. Make sure you guys do know how to get that on your calculator, because that's what we're going to be doing for the rest of the day. But we could do this one in our head, but I just want to show you the change of base formula works, and it gives us a good answer. Now let's go back to this one. We saw this one earlier, right? Well, we realized that 4 to the first power is not big enough for 10, and 4 to the second power is too big for 10. So we don't know what the answer is, but we do know it's somewhere between 1 and 2, right? But using our change of base formula, we can actually get a very exact answer. So we're going to do log and log. The top number is the 10. The bottom number is the base. And we're just going to type that into our calculator. Now, once again, go ahead and type that into your calculator however you need to. Different calculators work differently. But type it in, let's see what we get. You should be getting something between 1 and 2. I'm getting 1.661. 1.661. All right. So there's our answer. You could check that too if you wanted to. You could try what is 4 to the power of 1.661. You should get something really close to 10. Okay. All right. So that's the change of base formula. So let's go ahead and do a couple of these just to kind of practice some more. So example 1. What is log base 5 of 20? Well, I can't 5 to some power equals 20, but I don't know what that power would be. There's no way to just do that mentally. So I'm just going to use my change of base formula. Log 20 over log 5. And let's see what we get as a result. We get about 1.861. All right. Let's go ahead and do the next one. Log base 6 of 100. So 6 to what power would be 100? Well, I don't know. You can't write 100 as 6 to a power. So once again, we're going to use our change of base formula. Log 10 on the top, log base 10 on the bottom. We're going to put 100 on the top and 6 on the bottom. And then we use our calculator from there. So for that one, we should be getting 2.570. All right, for the next one, log of 60. Well, it's got a base of 10 already, right? Well, I don't know 10, like what power would I have to raise 10 to in order to get 60? Well, there's not a nice answer for that. And so once again, we're going to use our calculators. However, for this case, you could do change of base. Don't write this, but you could do change of base. It'll work, but it's kind of pointless The only reason we do change of base is because our calculators only have log base 10 and ln. And so we have to change logs like this into base 10 so that we can do it on our calculator. But this thing is already a base 10. So really all I have to do is literally type this into my calculator, log of 60, and I'll be good. So in other words, if it's a base 10, you don't need to change a base. Just type it right into your calculator. Your calculator will tell you what the answer is right away. Same thing with ln. If you guys ever see an ln problem, you could just type that right into your calculator. You don't have to do change of base there. Even though this means log base e of 3, and I have no idea what power I'd have to raise e to in order to get 3, you could do log 3 over log e. It will give you the correct answer, but it's kind of pointless because we already have an ln button on our calculator. So just push ln of 3, and you're going to get 1.099 approximately. Okay, so that's our example. So use the change of base anytime you can't write this number as a power of this number. And if you can, then just do the math mentally like we have in the past few lessons. But if you come across a base 10 or a base e, well, really you just need to type it right into your calculator the way it looks. All right, so here's 2 problems for you guys. Go ahead and pause the video here. Give these a try. When you unpause it, you will see the solutions. All right, so number 1, here's your change of base formula, and there's your answer. So 3 to the power of this would give you 60. Okay. Now number 2, here's our change of base formula, and here's the answer. However, just so you guys know, I didn't even use my calculator for this one because this is one where you can do it mentally if you think about it. This is basically saying 4 raised to what power would give you 2. Well, think of that what as an x. This is 2 squared. And you could solve it the old school way that we've learned before. X is a half, or in other words, 0.5. Now, I did that in my head just because it's a little bit easier for me being a math teacher, tons of practice. But my point is that this problem doesn't require a calculator. You could have done it in your head. But the calculator works. The calculator won't let you down. Change of base always works. Okay? So, there it is. So now we're going to do the same kinds of problems. We're just going to take it up a notch a little bit with the order of operations. But other than that, it's pretty straightforward. So here we go. I'm going to start off here with number 1. We've got f of x is equal to 5 log base 2 of 3x plus 4. Now I'm going to leave the x as a blank set of parentheses because we're about ready to plug something in. Because the problem tells me to find f of 10. And what that means is we want to replace the x with 10. Here and here. All right? Order of operations matters here, you guys. So parentheses are first. So we want to simplify this first. 3 times 10 is 30, plus 4 is 34. There we go. The next thing that we want to do is we want to simplify this piece. Now, what power would I have to raise 2 to in order to get 34? Well, you can't. There's no nice number that you could raise 2 to in order to get 34. So for that, we need to do change of base. Log 10, so I can use my calculator. 34 goes on the top, 2 goes on the bottom. So what I've done is I've changed this into this so that I can use my calculator. So let's go ahead and do that. Let's get our calculator and let's figure out what log 34 divided by log 2. And I'm getting 5.087. Let's round it at least to the thousands place. And then from there, after you do parentheses and after you do your log, then you're going to do multiplication. So let's multiply that times 5. And then after that, finally you do your subtraction. So there's my answer. So that's what you would get by plugging all that in. So when I plug in 10 for x, my output, my y value would be 17.437. All right, let's go ahead and take a look at number 2. Number 2, I'm plugging in 12. So let's do that. All right. So what would I do first? We said let's do the parentheses first, right? So 2 times 12 minus 1. That would be 23. What do I do next? We're going to simplify this expression here. I can't find out what power I would raise 7 to in order to get 23. So instead I'm going to use change of base. And we're going to do log base 10 over log base 10 with 23 on the top and 7 on the bottom. And from there, we'll let our calculator do that for us. So log 23 over log 7, I get 1.611. Then we do our multiplication next. I get negative 4.834. And then finally, we add 5 to that. And there's my final answer. All right, so let's go ahead and do one more. So we want to find f of negative 8 for number 3. Right? So once again, we're going to square that. Do the inside parentheses first. Then we're going to do this. Now, do I need change of base for this? We don't, because it's already base 10, right? So there I can just type it right into my calculator just like that. My calculator can tell me right away what is log of 64. In other words, what power would you have to raise 10 to in order to get 64? And the answer is 1.806. And then from there, we'll just use our calculator for the rest. I'm going to multiply it by a half now. On my calculator, I'm just going to multiply it by 0.5 because that's what 1 over 2 is. And that gives me 0.903. And then we're going to subtract 10 from that. The final answer is negative 9.097. Okay? So here's some student practices for you guys. Go ahead and pause the video. When you unpause it, you will see the solutions. All right, guys. So there you go. Those are your solutions for numbers 1 and 2. All right, and that'll do it. Pretty quick and short lesson there. We'll see you guys in class. Practice this stuff. Have a good one.